want to tell everybody thank you very much for coming to the webcast today. We have one vision that everyone can contribute. This underscores everything we do, and GitLab is used by 100,000 organizations, so I thank you very much for joining us to learn more about using GitLab. GitLab is where you collaborate on your projects. We have an issue tracker with merge requests, and we manage this through code review. And we also have a monthly release, and we work entirely in the open. And the great thing for you as a user is that you never really have to guess what we're up to and what we're doing. So we have an open development, open direction, and open strategy. GitLab comes in 2 versions. That's the community edition, which is completely open source, MIT licensed, and available to run both on premises, or you can actually use our service githost.io. The enterprise edition is our paid for licensed edition, and with that you get additional features that suit larger projects and sometimes more complex projects. They don't necessarily need to be larger, but in addition, when you're using Enterprise Edition, obviously you're paying a fee to help support our work, and at about $39 US per year per user, it makes a big difference to us. So if you're watching this as an EE user, we really thank you for your support. And however, if you want to try out EE or GitLab itself, and you want to do this for free, quick way to get started is right on gitlab.com. It's free and unlimited private and public repositories. It's basically the SaaS version of our Enterprise Edition. So that's actually what we're going to be looking at today. And what we're going to be talking about today is, I should introduce myself quickly. I'm Heather, Developer Marketing Manager here at GitLab. And our team is going to be talking to you with about a GitLab CI overview. Camille's going to talk to us about that. We're going to see how GitLab CI works. And we're going to see 2 demos. That's configuring CI for testing and then configuring a specific runner. Then Kimmel's going to take us back and talk to us about reviewing your work and also the roadmap and what's coming next. We're going to talk a little bit as well about the resources available to get started. If you're watching us live, you can download a handout that has all the links you're going to see in the presentation, as well as these slides if you want to see what's coming next. And if you're watching this on a recording, you'll be able to probably watching this from the blog or maybe on YouTube. You can sign up to our newsletter so you don't miss the next one. If you're watching us on GNU Linux, please try Chromium or Chrome. We've heard that the sound is better, so if you are having sound issues, that should make it a little bit better for you. So as I said, we're going to be doing this introduction to GitLab CI. And we have the entire CI team here today, which I'm really delighted about. Some of the technical hiccups you heard earlier was because we're trying to connect everyone. They're also on GNU Linux, and we're trying to make it work. So Camille, can you tell us a little bit about yourself?
Hey, I'm Camille, and I'm glad to be a presenter today. I started working for GitLab by contributing GitLab multi-runner, and now I am leading the effort to make GitLab CI a complete solution. How about you, Grzegorz?
Hi, can you hear me?
Yeah.
Okay, hi, I'm Grzegorz. I'm really glad to be here. In GitLab, I'm working as a developer, mostly trying to make GitLab CI better. I'm also involved in issue tracker development. How about you, Tomasz?
Hi, I'm Tomasz. I work at GitLab as a software developer, and since February, I took over the maintenance of GitLab multi-runner. And I'm glad to be here today.
Fantastic. Camille's going to give us that full introduction to GitLab CI, so over to you, Camille.
Thank you very much, Heather. As you know, the first question that arises is basically, what is GitLab? GitLab is a platform to collaborate on code. GitLab includes Git repository management, code reviews, issue tracking, and merge requests. Merge request is a place where actually you discuss your work. Merge requests have similar features to issues, such as comments, assignments, and the ability to add labels and milestones. The main difference between issues and merge requests is the line-by-line code comments, for example. And since GitLab 8.0, CI is a part of GitLab platform. GitLab CI is an easy-to-use continuous integration and deployment tool. Continuous integration has become pretty popular term in recent years. Martin Fowler has been famously been a champion of this practice. That continuous integration is a software development practice where members of a team integrate their work frequently, and this process is verified by automated builds to detect integration errors. CI is basically part of your workflow. It's not something separate. It's there to help you with reviewing the process, reviewing the changes. Continuous integration ensures that any change you introduce in your code doesn't break other parts of your application. This workflow requires that you write tests for all aspects of your application. Then, as your application grows, you're able to ensure that an existing parts of your application behave as when you created them. Say, for example, you have a team of a few people working together. You are not just reviewing the changes. You are also reviewing the results of your tests, ensuring that they do pass on your server. CI, basically, it's there to build confidence in your code. You know that if all tests do pass, then you can merge your code change, and you have this confidence that application won't break on production. Recently, continuous delivery and continuous deployment have become much popular. Continuous delivery is a practice where you deliver every change to a production-like environment, and through rigorous automated testing, you ensure that every function of your application works as expected. Since every change is delivered to a staging environment, using complete automation, you can have the confidence that application can be deployed to a production with a push of a button when requested. You can have a team to actually review this staging environment. Continuous deployment is a next step to continuous delivery. It basically says that every change that pass automated tests gets deployed to production automatically. GitLab, and specifically GitLab CI, can be used for every workflow, including the described here continuous delivery and continuous deployment. In GitLab, we decided that the best way to describe your workflow is to use simple text files, specifically the YAML syntax. These files that are version controlled and are part of your repository. As developers, we prefer to work with code, so this is really natural environment for us. A GitLab CI configuration describes your environment, describes how to build and how to test. This configuration file is used to define stages of your pipeline, including how to deploy your application. Being a part of the repository allows your team to collaborate on improving this configuration. For example, pretty live example, that you are not required to go to administrator to add build to your project, because you have this power to make this configuration, to add this new test. You can use GitLab CI for every project hosted on GitLab. Let's look at this very basic GitLab CI YAML. The configuration file defines a set of commands that will be executed to test or deploy your application. The example file describes two tests. First one is RSpec, and the second one is Robocop. In the example, we use Ruby image. The same Ruby image that you can find on Docker Hub. GitLab CI is tightly integrated with Docker. Worth noting is that you are not only limited to Docker-based workflow, but you will learn from Tomasz more about the CI for different platforms. In the before script, we first install all dependencies required by your application. In this case, it's just bundle install. And secondly, we run our testing framework to execute tests. In this case, it's RSpec and Robocop. As you can see, this configuration is really simple, it's text-based, and it's really clear what is happening here. Grzegorz will show an example how to start with CI in just a few minutes. GitLab, you can ask yourself what you can do with CI on GitLab. GitLab is a very flexible tool. You can run any test suite on any code. You can use Docker to build your Docker images and push them to the registry. You can use any operating system. It can be Windows, Linux, FreeBSD. You can use any language, any framework. You can even build your mobile applications for iOS, Android. And what is really important in the world of Internet of Things, you can also use GitLab CI for embedded development. This includes running your tests on ARM and Raspberry Pi. Isn't it awesome? And you may be interested to know more about the architecture. Architecture actually of GitLab and GitLab CI is really simple. GitLab basically consists of two applications. One is GitLab, which is used to manage your repositories and for coordinating your builds. And the other one is GitLab Runner. This is the application. This is basically used to run builds on your machine. This can be, for example, a virtual machine. It can be dedicated server, but it can even be your laptop that you are using on daily basis. It's important to know that runners can be specific to your project or be global to the GitLab installation. This allows you, for example, to use different runners, multiple runners to parallelize builds across different machines. This makes it possible to test your application in different environments, on different architectures, and different systems. With GitLab 8.0, we integrated CI into GitLab. We always felt that CI should be transparent to users and automated. CI should be built in a way that doesn't require a lot of developers' attention. Developers should basically focus on reviewing changes and writing tests. They should pay attention to their builds and whether their builds are passing or not. By having the CI as part of GitLab, we achieve that. Developers don't need to care how CI infrastructure is maintained anymore. They do care about reviewing, testing, and just improving their application. You may be interested in how we integrated CI into GitLab. Let's start with this main view of your projects. You will see a green tick mark on the right that indicates that your project have been verified by GitLab CI. If you see the project landing page, you can also see the status of your latest changes in very clear and nice way. You can also go to the builds for your project. You can access that option from the same panel that you access a list of recent commits, see a list of issues, or review merge requests. Just click the builds option on the left sidebar. In this view, you can quickly click the status or build number to see details of interesting build. You can also quickly access the changes introduced by tested commit. Here, on the list of commits, you can see the status of every commit and all builds that were created per commit. If you navigate to the build log, you can see detailed information of the specific build. If you navigate to the list of merge requests, you can see at a glance which merge requests were verified successfully, which are currently building, and which have failed and require your attention. If you navigate to a merge request, actual change, you can review that change, but you can also see the status of this merge request. You can accept the changes or merge when build succeeds. This is pretty awesome feature because merge when build succeeds means that this merge request will get automatically merged only when all tests do pass. This allows you, for example, to review the changes and start working on different features because GitLab CI will ensure that this change is safe and can be merged to your application and doesn't break your other parts of this application. If you are wondering what other CI system GitLab works with, some of the presented integrations will work with other systems, but not all. Of the other tools, Jenkins has the best integration. You will see the status of commits, you will see the merge requests, you will see the status of builds, but for example, you will not see the detailed information about build, nor be able to download or browse build artifacts that can be used with GitLab CI. Here is a list of example CI systems that GitLab works with and what can be used. You can access these services by going to project services, clicking the specific service and integrating that service following the documentation as it's on doc.gitlab.com. I hope that you did find an overview of GitLab CI features useful. I'm sure you have a lot of questions. We'll be seeing two demos, which I think will answer more of the how-to questions you can have. I just wanted to cover some essential concepts. Heather.
Now we're going to actually get a demo from Grzegorz, and he's going to talk to us actually about runners. And can we hear you, Grzegorz? Can you hear us?
Hi, can you hear me?
Perfect.
Okay, so I suppose that we will show you a video, right? Are we on this stage? Because I wasn't able to keep
Yep.
track on. Okay, so yes, thanks. So we wanted to perform a live demo about configuring an example application, but due to some limitations, we will show you just a recording. We will see how to create an example Ruby project from scratch and how to integrate GitLab CI into it. It can take just about 5 minutes. So let's watch it. Here we have a new example Ruby project. I will use the RSpec test harness and show you some test-driven development techniques. I'm going to show you how to set up CI environment for your new project on gitlab.com. It takes just about 5 minutes. So let's start with creating a new project directory, initializing an empty Git repository and the RSpec framework. Now we create a scaffold for our class called dog. We saved it in a dog.rb file. We should also configure the RSpec framework and load our dog class in spec helper rb. Then we run RSpec and see that it works, but we do not have tests for our class yet. 0 examples, 0 failures. So now we need to add tests for our project in dog spec rb. One simple test for method called bark will be enough. We expect that bark method defined in a dog class will return a string. After running tests, we can see that the tests are failing because we do not have an implementation of bark method yet. So let's add it and run RSpec. It should succeed. Now the test passes. One example, 0 failures. Okay, so we need to configure CI environment in GitLab now. We do that by adding a GitLab CI YML configuration file. Initial content can be really simple. I will explain what we have included in this example. We will run our tests in a Docker container, so we need to specify the Docker image. We use a Ruby image here. Next, we need to define a new CI job. So we add an RSpec job that will install RSpec framework and run it. You can have multiple jobs and plenty of configuration options. Please check our documentation for more information. Now we can commit everything to our Git repository. Next step is to create a new project on gitlab.com. You can of course use your on-premises installation too. This works in both GitLab Community Edition and GitLab Enterprise Edition. Our new project on gitlab.com is called CI Example Ruby. We can now add a remote to our local Git repository and push our changes. After visiting our project page on gitlab.com again, we can see a new commit and a new build that has been triggered, and we can see that it is running now. Let's take a closer look at a build log. Build succeeded. Let's see what happens when a build fails. Let's modify the project to change the return value of the bark method. After pushing these changes, we should see build status of our recent commit. Here it is in the build log. Build failed. Okay, so there is an error, which of course we expected. Now we can fix it using GitLab workflow. We'll correct our dog class implementation and submit a new merge request. We create a new fix branch, we fix the implementation and push changes to gitlab.com. On a page that contains the list of builds, you can see that builds for commit on our new branch are pending. That's because we use shared runners on GitLab.com. These need few seconds to spin up. By the way, did you know that shared runners on GitLab.com are currently free for everyone? In the meantime, we can create a new merge request. Our aspect job should start running within a few seconds. The RSpec job is running and it should pass. Our changes have passed the test, so we can now merge our merge request. Changes that fix our project have been merged, and that's it. Thanks for watching.
Yes, Grzegorz was talking about bootstrapping simple project and creating a new project on GitLab and adding the CI configuration to this project. We use RSpec as our testing framework, and we did configure the CI environment for it on gitlab.com. And we did see what we can do with this change. We did show the merge request workflow, and we did finish that with a successful merge.
Brilliant. And I think at this stage, we are going to hear from Tomasz, who's going to talk to us about configuring specific runners. Just want to make sure that we can hear Tomasz.
I will just play the Tomasz demo. So I will just later.
Sometimes you may not want to use the shared runners. For example, your project needs to be compiled for Windows or OS X, or maybe you create some confidential data inside your build and you need to have them on your infrastructure. Happily, GitLab CI gives you the possibility to run your builds on any machine, even on your laptop. In this demo, I'll show you how to add a specific runner to your project. We have here an example project with some builds executed with the shared runners on gitlab.com. You can see this here in the build log. Now, let's register a specific runner for this project. Let's log in to a fresh Debian Jessie virtual machine where there's no GitLab runner installed yet. We can check this by executing the command gitlab-runner --version. And as we can see, the command is not found. So, let's go to packages.gitlab.com, copy the quick install script and execute it on the virtual machine. This script will add the Debian repository with the GitLab runner packages. After this, we can install the package itself, so we'll use this command apt-get install gitlab-ci-multi-runner, and we'll wait a few seconds until the installation finishes. Now we can again check if the binary exists with the command gitlab-runner --version. And it is. The package also installed the GitLab runner service, but we'll stop it for now with gitlab-runner stop. We'll activate it again at the end. For the first test, we'll run the runners process manually. Let's get back to the project, open the settings page, and from there open the runners page. What we can see here? We can see that we have enabled shared runners. We have also available some specific runners. Those are runners from my other projects where I have master access. For security reasons, tokens of the runners are of course hidden. And we have data needed to register a new runner to this specific project. Let's run the register command, gitlab-runner register. We will need the GitLab CI address. Let's copy and paste it from the runners page. We need also a registration token, which we can also get from the runners page. Description let's leave as it is, and let's name the runner test runner. And for this test, we will use the shell executor. And that's it. The runner should be registered now. So let's refresh the runners page, and we can see that for this project we have activated a specific runner. Here we can see this runner's token. This token is used in the config.toml file, which contains the configuration of the runner. So let's disable the shared runners, and from now on only this one specific runner will execute our new builds. Let's go back to the builds page and run the last build again. We can see that the build is stuck because we registered the runner, but the process is not working yet. Let's start the runner process with GitLab-runner run. And in the background, we can see that the build started. And it ended with succeed. So I will stop the process for now. And in the build log, we can see that the build was executed on our virtual machine. So at the end, let's go back to the virtual machine. We'll start the GitLab runner service with GitLab-runner start. We can check if it is running with command GitLab-runner status. And from now on, the runner process will run and execute new builds even if the virtual machine gets restarted. And that's all. 5 minutes and a new runner is registered and ready to work for your project.
Okay.
Fantastic, Tomasz. Tomasz is going to talk to us a little bit more about using a runner.
So you did see the video, you did see the recorded Tomasz demo. Tomasz did install GitLab Runner on fresh virtual machine with the help of Debian package. He did register Runner in a project created earlier. He showed you that you can disable shared runners and provide your own specific runner, and this runner can be run as system service that will be used after that will be process your build after you restart your machine. You can ask yourself, why would I need my own runner? Thomas said earlier that the short answer, because you can. But in GitLab, we value that as the same as we have for Docker, that you can bring your own image for Docker for testing. The same we have for the runners, that you can bring your own runner, because we are unable to cover all possible scenarios that can be used, that GitLab CI can be used with. GitLab CI, by having your own CI runner, it makes it possible for you to prepare basically your own build environment. So if you want, you can use the shared runners if your GitLab installation has some. But if you need, for example, to build your project on different platform, for example, it can be you want to build your iOS application, most likely the shared runner that are provided with GitLab installation will just be not enough. And the second case, you can think that you may want to leave the confidential data on your infrastructure. Let's assume that you have pretty important deployment, you have access to specific production servers, and you don't want these servers to be exposed to outside network. With that, you can basically you can achieve that, you can deploy to that server by providing your own runner. shared runners. On shared runners on demo, Thomas showed that we used GNU Linux as runtime platform, but the important thing is that we are not only limited to Linux. You can basically run GitLab Runner on anything that can support Go language. So GitLab Runner is written in Go. You can run your runner on Windows, on OS X, on FreeBSD. These are just 4 of our supported platforms. And we do provide a nice installation possibility by using just dep and rpm packages that are prepared for your Debian or CentOS distribution. On each platform, you have this possibility that you can run builds in different way by using the concepts that we have named executors. Some of them are available for all platforms, but some of them are platform specific. But thanks to that, you have this big flexibility that GitLab CI provides. Like Thomas said, we have these different ways to run your builds. By default, we provide two examples. One is the shell executor, and the second one is Docker. Shell executor of all is the simplest executor that you can use. It's basically available automatically after runner's installation. It can use B to host. It uses your host environment with all its benefits, but it has this one disadvantage that is potentially less secure because you don't have this separation of resources. Each project that have access to the working directory of other projects. Each project can have access to the working directory of other projects. So basically, the shell runner should be used only for your projects on your trusted infrastructure and on the infrastructure that you have full control of. On the other hand, we have this flexible Docker executor that gives you the power of separating your builds environments. It's way powerful than shell executor because it basically can provide you a clean build environment every time you run your build, but it also allows you to bring your own image just to be used for testing your project. It only has one disadvantage. It can be sometimes pretty big disadvantage that you can use this runner on, that you can use this executor only on Linux, because right now Docker is well supported only on Linux, but we do plan that in sometime in the future you will also be able to use Docker executor or on Windows. And finally, recently with GitLab Runner 1.1, we introduced autoscaling. Autoscaling uses Docker machine. It's basically meant to manage your infrastructure. So basically, GitLab Runner becomes a little like a manager of cluster. GitLab Runner in autoscaling mode works pretty much the same as Docker executor, but with one big advantage, that it will automatically scale using selected virtualization platform or any cloud provider. It allows you to follow your number of builds. If you happen to have way more builds during your workday, GitLab Runner will automatically have more machines that will be able to process that builds. It basically follows your day cycle, and by using autoscaling, you can basically speed up your builds on the first hand. On the second hand, you can reduce the build times by having the shorter wait queues. And the third and the fourth thing is basically reducing the cost of your infrastructure and managing overhead of your administrators. So as summary, autoscaling basically it's a big deal because it allows you to increase the happiness of your development team. I think that this is all that we had about GitLab Runner. So, okay, a lot of stress today. So let's continue, and we'll just finish after this part. I did say a few words about the build artifacts. The build artifacts is a pretty pure feature. You can find that in other products. But basically, the build artifacts allows you to generate files that are then later uploaded to GitLab. These artifacts can be downloaded and browsed afterwards. This allows you basically to archive application logs, archive binaries, have the packages generated by your builds, or just use the build artifacts to pass the information between stages. Recently, not really recently, but for some time, we have this awesome feature. It's named GitLab Pipeline. GitLab CI allows you to basically specify in which order you want the jobs to be run with GitLab Pipeline. In this example, we define two jobs. One is the build, and the second one is test. The test will only run when the build stage succeeds. With the previously mentioned build artifacts feature, you can pass data between stages. This allows you to generate binaries, archive them, and for example, if you need, you can use the same binaries generated through GitLab Pipeline to perform deployment of your application if you are required to. As part of GitLab Pipeline, we thought that we can allow you to parallelize your jobs. It's basically made for speeding up your builds. The jobs are grouped into stages. The jobs are defined for the same stage, are always run in parallel. In this example, we have two defined jobs. You can see the test 1 and test 2. These jobs are meant for the same stage named test, and these two jobs will be run in parallel when triggered by GitLab. It basically allows you to go from this sequential model of executing your jobs to a parallel model when you actually can cut your testing time in half. Can you think about this big advantage that you will have when you add to that auto-scaling? For example, on GitLab CI repository, we actually have 16 different jobs for different test suites. So basically, we are using high parallelization of GitLab CI testing framework. So it basically, from the 4 hours, can allow us to shorten our testing time of single change to around 30 minutes. It's a really big gain. As said before, we have this big thing. It's Docker support. It's part of the Docker executor. It's something that allows you to bring your own image. You can, for example, have your own Docker file. You can build your Docker image, push that image to Docker registry, and use that image, use that definition of that image in your GitLab YAML file. In the example above, we define one test that will be run against Ruby 2.1 image, Ruby 2.1 image. You can find this image just by searching the Docker Hub. And we also have this services addition. Services are also just the Docker Hub images, are also just Docker images. In the example, we have the MySQL database that will be created just for the time needed to execute your job. It's important that every time that you execute this job, you will get a new clean environment and a new clean database. So basically, this allows you to have reproducible builds that always start from the same state. Recently, we introduced GitLab Pages. We got really a lot of nice feedback about the GitLab Pages. GitLab Pages are meant to allow you to create a website for your GitLab projects. The big advantage of GitLab Pages is that you can use any static website generator. You can use Jekyll, Middleman, Hexo, Hugo, Pelican, or it can be even your page generator. You can use in GitLab Pages, to provide GitLab Pages, we use the full power of GitLab CI. GitLab CI basically builds your page and uploads this page as the build artifacts to GitLab. On the right, you have the example YAML file that uses that builds your repository, that builds your Hugo-based GitLab page. What is important that your site is served by high-performance GitLab Pages daemon, which is completely written in Go. This enables us for you to provide your possibility to define your own domain, and you can use also your own SSL certificate to secure your page. In the future, you can expect that we'll add support for Let's Encrypt that will allow you to secure pages by default. So you will have this certificate generated by us, maintained by us, and renewed by us. There is also another feature that can be really useful. You can verify the validity of GitLab CI YAML. If you go to the builds page and click the CI link on the right, you will go to this form where you can paste your GitLab CI YAML and verify the validity of this file. It allows you to find potential problems with your GitLab configuration. But these are just a few of the features that we have now. In GitLab, we have this strict release cycle that we release a new version of GitLab every 22nd of the month. We release new features basically every month. In one of the upcoming releases, you expect that you will have the container registry as part of GitLab platform. This will allow you basically to build and push your Docker images back to GitLab. You will allow you to use your Docker images to deploy your application with upcoming support for deployments to Kubernetes and Docker Swarm clusters. But we are also thinking about how to make complex scenarios simpler. And this will be done by support for plugins in GitLab Runner. Right now, we are required to have a script pretty much for everything. With the help of the plugins, we will simplify the way you build your Docker images. We'll also be able to integrate Docker Compose-based workflow, but we'll also introduce support for code metrics and code metrics that are provided by external companies. Last but not least, this is something that we are also constantly working on, is the artifacts feature. For example, it will be possible to have artifacts for failed builds and to pass artifacts between dependent projects. This is not all. You can find information about GitLab and what we do and what is planned ahead just by going to about.gitlab.com/direction. You can also contribute to the feature that is listed there or just propose your own feature.
Fantastic. Thank you so much, Camille. We have some great news. We were able to load up a question, and it's a really good one, actually. We'd like to know, this is actually related again to the question about shared runners. Are configuration files in the container server passwords safe on GitLab.com if we don't use a shared runner? Maybe we could talk about security and shared runners versus specific runners.
Can you reply the question once again?
Well, actually, I think the question is generally, if you have information like, container server passwords, if you're using secure information in your repositories, are they safe on GitLab.com if they don't use shared runners? And the question of security did come up when we talked about shared runners versus specific runners. What are some of the security issues?
Okay, so the answer is really simple because we have this feature named the secure variables. These are part of your project. It allows you to put some secure data like private keys or passwords. And in case of the shared runners, we did upgrade the shared runners recently, and we are committing that these shared runners are secure just by following the best practice that VM that is used by your build is just used once. So the variables, the passwords are stored on GitLab, but they will not be accessible in any way to other builds from other projects that can be run on the single machine, because this is something that doesn't happen. Because after your build, we just wipe out the machine and start a new one.
Mm-hmm. I think that definitely answers the question. Another good question, you mentioned that we're developing a registry, but this person wonders, do they have to make their Docker image publicly available on Docker Hub to use it with GitLab, or can they use a local image?
Yes, currently this is a requirement that Docker image has to be public. But this is something that we are working with as part of the plugin system that you will be allowed to put your Docker registry credentials to external services, to any Docker registry, into GitLab. So basically, you will be able to put the username and password to access this image, and these credentials will be passed to GitLab Runner so that GitLab Runner can download that image. So to summarize, currently it is not possible. You are required to use the public image, but this is something that will be improved in one of the upcoming releases.
Brilliant. And someone asked a question about using pages. As we sort of maybe referred to pages, can you use it with self-hosted GitLab or GitHost? You can certainly use it with either your on-premises yourself or in GitHost if you're using the Enterprise Edition. So absolutely. Another question is it possible to control actually how long these artifacts are kept for?
This is a feature that was supposed to be shipped in 8.7 release, because we thought that, and we had the complaints from the users, the developers, that we don't have the facility to recycle old artifacts, but we are doing so many different things at once that we did not manage to ship it. So this feature is right now planned for 8.8. It will basically allow you to, in your GitLab configuration file, specify that these artifacts for this build will expire after, for example, 7 days. This way, you will not run out of the space on your GitLab installation. Currently, we have a guideline how to remove them manually if you have access to GitLab server, but this is not yet automatic. It will be in next release.
Excellent.
The next, I mean 8.8.
Very good. And we can probably follow up in the blog post and link off to the issues to see what's happening. I wonder, someone asked just about integrations. I know you mentioned what we work with. Someone asked, can you use GitLab CI with GitHub? It's
possible, but you are required to mirror repository. So for example, if you have your GitHub repository, you can use gitlab.com, create a repository mirroring. This is a feature of GitLab EE. This will basically allow you, not really allow, this will make the GitLab to constantly watch your other repository. It may not only be GitHub, but it can be pretty much any repository. So with this feature, you can use CI of GitLab using some other repositories, but your code needs to be stored in Git repository hosting in some way or another. Basically, it can be done just by mirroring, which is the feature of GitLab EE edition.
Excellent. Fantastic. That's really good. As I didn't expect that answer. I thought it was just a flat no, but I like the way there's always a creative solution. So I'm going to jump ahead to the next slide, which says everyone can contribute. Of course, I can't see that slide. I hope you can. And you can actually click through to read our strategy document. And it's, recently we clarified our mission to change all creative work from read-only to read-write so that everyone can contribute. So this is important. I mean, if this whole idea of being an open company is important for you as a user, again, because you'll be able to see why we're making decisions and why we do what we do, and you can actually influence that. You can actually even make suggestions even on the strategy document. So on to the next slide, I would like to say thank you very, very much to the GitLab CI team. That's Kamil, Grzegorz, and Tomasz. They did a lot of preparation for this.
Yes, thank you very much for attending this webinar. I'm really grateful. We had a really great time trying to prepare that, and we are really looking forward to your question. We'll answer everything. You can, for example, create the issue on issue tracker, or just ask us on one of our blog posts, or just send the question to the EARS channel that is on Freenode.
Yeah, that's right. Definitely. IRC is great. So thank you, Kamil. Thank you, Grzegorz, and thank you, Tomasz, for all the work you did. And we'll see you guys online. Goodbye, everybody. Bye.
Goodbye.